Hi, my name is Raphael, and this is the second tutorial on using HAL, the hybrid agent-based library. And in this tutorial, once we have HAL set up, we're just going to build a simple on-lattice model as a nice starting point to see how some of the framework components work together. So the first thing that I like to do when I create a new model is make a new project directory that's going to hold all of the class files for that model. So we'll just make that under new package. So I got to this menu by right-clicking on the root directory. We're just going to call this on lattice example. And then here, inside of this package, we'll make a new Java class, and we'll call this class the example grid. So this is the grid that's going to hold the agents. So one of the main ideas of the framework is that for agent-based modeling, you create a grid and an agent class, and the grid is going to hold our agent. So we're going to make another class called example cell, and that's going to be our agent class, and it's going to live in the example grid. So in order to complete this sort of grid agent relationship, we have to make both of these extend their respective framework types. So the example grid is going to extend one of the agent grid types. So we're going to make a 2D model, so we're going to extend agent grid 2D. Oops. And then we're going to make the example cell extend agent SQ for square, meaning that it's going to be on a lattice of squares, and it's going to be two-dimensional, just like the grid. And we're going to pick the unstackable agent type, which means that you can't put more than one example cell on the same lattice position. It'll throw an error. And that can be nice if you want that assumption for your model. And so in order to complete this agent grid relationship, both of these need a type argument as well in their definition. So the grid needs to know what kind of cell is going to live on it, and the cell needs to know what kind of grid is going to house it. So we're just going to put in the names here. So this agent grid 2D is going to hold example cells, and this example cell is going to live on an example grid. Now you can see that we're getting another issue here that we have to do an import. It doesn't recognize this agent grid 2D type at the moment. So you can just do Alt-Enter, and it'll automatically import. And you can see there's another error as well, so I'm just going to do Alt-Enter again to see what potential solutions the IDE recommends, and it says it wants a constructor. So the agent grid 2D has a constructor in it, and in order to extend that class, we need to make it a constructor that calls the agent grid 2D's constructor. So the example grid is going to have its own constructor, and it's going to call the agent grid 2D's constructor inside of it. And to that, we create a constructor like so. And so it automatically fills in some of this. We don't necessarily need that. So the arguments to this constructor are the x and y dimensions of the grid. And we're going to feed one more argument in, and that is the class type that the grid uses. And it's going to use this argument to create agents when we call for them. So we're just going to give it example cell.class. And so this is the sort of complete grid agent relationship. So it's a useful starting point for any model that's going to be agent-based, is to sort of set this basic thing up. So we could do a couple different things from here. We could define some of the grid functionality, or we could define some of what the cell does. And I'm going to pick defining the cells functions, and then we're going to fill in the rest of the grid information as well until we get a model we can run. So the first thing to do here is we're just going to have one function, and that's going to be called step cell. And that's going to run the cell's it's going to be what gets called every step or every time step on the cell. We're going to give it a die probability and a division probability. And the idea is that we're going to use a random number generator to test against these probabilities, and if it's determined that the cell will die, then it will die. If it's determined that it should divide, then it will divide. And this is going to happen every time step. So in order to do that, we need to define a random number generator. And we can do that in the example cell just fine. So the framework random number generator is called rand. So we can just say rand RNG equals new rand. And then you can see it once again wants to import, so Alt Enter. Now, we could have the generator defined inside of the cell, but that means that every time we create a cell, it's going to also create a random number generator. And we don't necessarily want that because we can instead just recycle the same generator for every cell if we just put it in the grid instead, because all of the agents have access to the grid that they live on. So long as we have a generator in the grid, we can use it, but with the cells. So I'll show you how that works. So the first thing we'll do is we're going to check if, and then we use this function called the G function, and here G is just referring to the grid. So if my grid dot RNG, as in the random number generator we just defined, dot double, which gets me a random number between 0 and 1, is less than our die probability. So if our die probability is, say, 0.1, then our random number generator is going to, about every 10% of the time, come up with a random number less than 0.1, and that will fire this if statement. And here we're just going to have the cell die. We'll return after that. So if the cell dies, then we just exit the function. But if the cell doesn't die, we can check if it will divide. So if our random number generator double is less than the division probability, then the cell will divide. So now let's fill in these if statements. So if it's time for the cell to divide, then we call the dispose function. And what that does is it basically gets rid of the agent and pulls it off of the grid. And then we'll return after that. So if the agent is going to divide instead, then we're going to check the neighborhood around the cell looking for an open position, and then if we find one, we'll allow the cell to divide into that position. So in order to do that, we need a neighborhood. And once again, this neighborhood object can be used by all the cells, so we're just going to define it in the grid and then reference it in the agent. So we're going to make a neighborhood, and neighborhoods in HAL are integer arrays. We're going to call it the division hood because it's the neighborhood that is used for cell division. And it's defined, so to generate a neighborhood, the function to do that is defined in the util class. So we're going to make a 2D neighborhood using the genHood2D function. And once again, we have to import util. And we're going to give it an integer array. So new int array, and then we'll define here what the coordinates are that are going to be included in the division neighborhood. So it's a 2D neighborhood, so we need to define 2 numbers per coordinate location. So we're just going to define what's called the von Neumann neighborhood. So that's 1, 0, -1, 0, 0, 1, 0, -1. So it's the 4 surrounding positions around the 0, 0 sort of origin position. So you don't necessarily have to define the coordinates this way. We can use a shortcut to generate the neighborhood because some neighborhoods are already built into HAL. So I'm just going to substitute this code for this. So you can see we have the von Neumann neighborhood. And it takes a Boolean argument as to whether or not we want to include the origin. So in this case, we don't want to include the origin because we're looking for positions the cell can divide in. And it can't divide where it's currently occupying. So we're just going to set this to false. And what this generates is ultimately the same as what this generates. So we'll just leave it like that because it's a bit shorter. And that's what we need now for the cell division. So we'll check if the cell will divide, and if so, then we use the division hood. So we use what's called the map_empty hood function, and that returns a number of options. So and then we're going to give it a neighborhood, and that's the division neighborhood. And what map_empty hood does is it takes a neighborhood and it maps it to a position. So in this case, it's going to be the position that the cell is currently occupying. And then it will find all of the empty squares around that position. And it'll return the number of empty positions it finds. And it will store the empty positions in the division neighborhood. So the next thing we can do is say if the number of options that we can divide into is greater than 0, then we can actually create a new agent. So we call from the grid new agent square, and then we can give it a location or an index. And here we have several options, but these options are put into the beginning of the division neighborhood. So we can say to get the division neighborhood, and then get the random number generator, and get an integer, which is going to be which index in the division hood we're going to pull out. And we want at most to be the number of options. So it'll be from 0 up to the number of division options. And so we're just going to create a new agent at some empty square, some empty location in the division neighborhood around our cell. So that's the complete cell step function. Next thing we're going to do is in the grid, we're going to define a model step. So let's build our step function. We're going to pass to that the same die and divide probabilities, so we'll actually be able to set those in the main function. And what we're going to do is just loop over every cell in the grid and call that cell's step cell function. So that uses a pretty simple for loop syntax. So we loop over every cell in the grid. So this here is referring to the particular example grid that we're calling step cells from. And then for each cell in that grid, we say cell.step cell, and we feed it the die probability and divide probability. And that'll call this step cell function up here. So this is all we need to do to step through every cell in the model and make it do something. Next up, we'll add a draw function. And that's going to take in an object called a grid window. So the grid window, when we pass it in, is going to have the same dimensions as the example grid. So we can loop over the entire length of the grid, which basically accesses every index of every position on the grid. And those indices will match with the grid window's pixel indices. So we'll be able to set the pixels on the grid window based on what's going on at each model location. So we'll make a color, and in HAL, colors are represented as integers. And there's some colors that come with the HAL automatically. So we'll use black in this case to represent that there's no one there. And if we don't find anyone, we're going to use that color. But if we get an agent at this particular index that we're looping over, and that agent is not null, meaning there is an agent at that position, then we'll set the color to be white. Once again, using the built-in constant for it. And then once we have set the proper color, we'll set the pixel using that color. So we'll set at this index, we're going to set the color to that color. And that's all we need to draw the model. So the last thing is a main function that will bring all of this together. So we'll make some dimensions for the grid. We'll have a certain number of time steps. We'll have a die probability for all the cells. Should make these doubles. And then we'll run our model step. And we'll run our draw as well. And to draw, we'll need to define a window. So grid window win equals new grid window. And we're going to set the dimensions to be the same as the dimensions of the grid. So x comma y. And the last argument here is a scaling factor, which says that for every pixel on the grid window, how many pixels should that on the screen should that pixel be wide and tall. So if I set this to 1, then every pixel on the grid window will match up to 1 pixel on the screen. If I set it to 2, then every pixel on the grid window will be 2 pixels by 2 pixels, etc. And we'll need a model as well, obviously. So example grid model equals new example grid. And we need to feed it the x and y dimensions, the same ones. And then we need a for loop that'll loop over all of the time steps. And then these two events will happen inside of our for loop. So the model step, we just call step cells from the model. And we feed it the die probability and division probability. And then we just have to draw lastly, so model.draw, and we'll give it the window. And so if I run this now, it should work. Fingers crossed. So now we have the complete design of all of the resources and the model step, but we forgot to initialize. So we can say model dot new agent square, and we're going to put this agent in the middle of the domain. So model.xdim over 2, model.ydim over 2. So that'll create a new agent right in the middle of the world. And then one more sort of modification that we should make before running this is we should add a pause every time step. And the way we do that is with the window. So win.tick pause. So this will have the model pause for 1,000 milliseconds after every time step so that we can actually see what's going on. So every 1/10 of a second, the time step will advance. So now if we run this, it should produce something. So you can sort of see that there. We have some white dots appearing, and those are the cells, and they're dividing, so they're producing more cells, and some of them are dying, leaving these black gaps. So it looks like this is a little bit slow for my taste, so we can speed it up a bit by changing the tick pause. And also it's a little small, so we can adjust that by changing the scaling factor on the grid window. So let's do those things. And run it again. Looks like our cell died this time. Let's try one more time. So here we go. So neat. You have a very basic on-lattice model ready to go. Hopefully all that was understandable, If there's any questions, feel free to leave them in the comments, or you can send me an email, whatever. See you guys next time.